Let's take a quick look at two-dimensional coordinate systems, and we're going to compare the polar coordinate system to the rectangular or the Cartesian coordinate system. So basically a two-dimensional coordinate system is a way to determine the location of a point in space. So for example, let's say I've got this point in space over here, okay? So let me draw it. There we go. If I want to know the location of this point in space, there's a couple different ways we can do that. Let me make a copy of this because we'll look at it in two ways. We'll do it in both coordinate systems. So over here I'm going to look at the rectangular coordinate system. The rectangular system. In this system, we move left and right. This is our typical ordered pairs are x comma y, okay? So in this case, in this system, we think of this as being the positive x-axis, this being the positive y-axis, and to locate this point, I need to know the x and y coordinates, the ordered pairs, or the ordered pair. So let's say, for example, that this point is 4 units to the left, so this would be -4 on the x-axis, and it's 4 units up, which means +4 on the y-axis. So in the rectangular coordinate system, this ordered pair would be -4, +4, x, y. Go left, go up. So it's called rectangular because you move left and right. Okay, very rigid, perpendicular movements. So another way that you could locate this point is to use what's called the polar system. Okay? In the polar system, you rotate and walk. Okay? The ordered pairs, I'll illustrate what I mean by rotate and walk in a minute. The ordered pairs in the polar coordinate system are written as r, theta. Okay? So the rotate comes from your theta, and the walk comes from your r. Okay, think of r as radius and theta as an angle that you rotate. So in this problem, if you wanted to get to this point, you could do the rectangular movement. You could move left 4 and then up 4 to get there. Okay, or you start at the origin, and if you're standing here, standing up on this origin, what you would do is you'd rotate to face this point. So that rotation would be something like this. You know, the angle 0 is on the positive x-axis, if you will. So you'd rotate from there around to look at this point. So now you're looking in this direction. So that's your theta value. So in this case, your angle is, let's say, 3 pi over 4. I won't talk about how I got that here. That's in a separate video where I'll talk about converting between these two types of coordinate systems. So now I'm at least facing this point. Now all I have to do is walk to it. Okay, so then I have to determine how far away is this point for me to walk to. So I rotate and I walk. And that distance, again, don't worry about how I get it in this video, is 4 times the square root of 2. So theta is 3 pi over 4, and r is 4 square roots of 2. So this ordered pair in the polar coordinate system is r comma theta, so 4 square roots of 2, comma theta, which is 3 pi over 4. Now one thing to keep in mind when you do this is I personally like to use my theta first, and that's the second coordinate. Your rotation is important, okay? Now, the theta value, theta always gives the positive direction. It's not like in the rectangular coordinate system where right is positive and left is negative, up is positive and down is negative. Over here, your rotation establishes the positive direction. So if you rotate to the 3 pi over 4 direction, then this direction is the positive direction. So I'd walk positive 4 square roots of 2. Another option would be to rotate to 3 pi over 4 and walk backwards this direction. This would be the negative direction, okay? So I just want to hint at this a little bit, that the positive direction is determined by your rotation, whichever way you're facing. That's the positive direction, and the opposite direction is the negative direction. Okay, so you'll see more about that if you watch any of the other videos on this topic.